Okay, so in this task, a Mamdani fuzzy logic implementation is done in order to develop a automatic gear change mechanism in a four-wheeler or in a car. So the two input variables are the speed in kilometer per hour or kmph and rpm, and the output variable is the gear number. So in this implementation, coding is done rather than using the MATLAB fuzzy toolbox. So first of all, the membership functions are defined. As per the problem statement, we are using four different types of membership function. The first one is a bell membership function. So it is a function of the variables and the parameters, where the parameters in a bell membership function are a, b, and c, and this is the standard formula for a bell type membership function. Similarly, defining Gaussian membership function, which is a function of the variables and the parameters in this case are sigma and mu, and this is the standard formula for a Gaussian membership function. The third type of membership function used is a triangular membership function, and the parameters a, b, c are defined. Then a matrix y is generated. Then we are checking if a is not equal to b, because this is the necessary condition to form a triangle. Then finding the index for this where x is lying in between a and b, and then finding corresponding degree of membership by the common formula. Similarly for the other side of the triangle, and finally setting y at x equal to b equal to 1. Why? Because the maximum value of degree of membership could be equal to 1 only. Then defining the fourth type of membership function, which is a trapezoidal membership function. So it is a function of the parameters a, b, c, and d. The two sides of the trapezoidal are defined similar to a triangular membership function. The only difference is the middle plateau, which is done in the second if statement by setting the membership degree of membership to 1. Then plotting the membership functions. So which is a function of the variables. Here in this problem we are having two input variable and one output variable. So array x is defined, which contains the values of the variables ranging from maximum to minimum value of the membership functions. Then switch case statements are used in order to plot all the membership functions one by one. And finally, x and y are truncated. X is truncated based on the range of the variable. Then the function fuzzy autogear, which is the main function to create the fuzzy inference system. In this, the fudgification of the input as well as output variables and the rule base is created. So first of all, defining a FIS structure, which is a structure of the inputs and outputs. So this structure contains the name, range, number of membership functions, and then further the membership function, which itself is a structure, are updated with the corresponding type, the name, and the parameters of the membership function. Like the first input is speed, range of the speed is 0 to 220, number of membership function is 5, and the corresponding 5 membership functions are defined here. Like a triangular membership function is used from minus 10 to 30, and it is defining as very long. Then overlapping from 20 to 50, another triangular membership function is used, which is defining a long. And then similarly, the whole input range for this speed input variable are divided by these five type of membership functions as very low, low, medium, high, and very high. Same thing is done for the another input variable, which is the RPM, which ranges from 0 to 6000, using similarly 5 types of membership functions. And the same thing is also performed for the output variable, which is gear, and which range is 1 to 5, and this is also updated. The whole range is covered with 5 type of membership functions. So fudgification step is done in these lines. Further, rule base is created. So in this, the first number represent the speed level, next number represent the RPM level, and the third number represent the gear number. And whether to use and or in between the two rules is defined in this matrix R. If two is used, that means it is an or, and if one is used, that means it should be and. Like if speed is very low or RPM is very low, then gear number is 1. If speed is low and if speed is low and RPM is very low, then gear number is 2. Similarly, all the 14 rule base are defined, and then the membership functions are plotted. Then in the rule viewer, the final combined plot by subplotting all the inputs for all the rules as well as the defudgification step using the method of centroid is performed. Numplot is the counter, final y is the array it is defined in order to get the final subplot for all the inputs and the corresponding output. And then in the first for loop, I is varying from 1 by 1 all the rules. Ymax 1 and Ymax 2 are defined for the maximum shaded area for both the inputs, and J is varying from 1 to all the variables, that is the two input variable and the output variable. And then subplot function is used to get the subplots, and the number of rows in the subplot will be number of rows plus 1, because there will be an extra subplot at the end which contain combination or union of all the rules, all the 14 rules. Then if the j is any of the two input variables, or it could be the output variable, then the next step is similar to a plot membership function, that is x array is defined, and then switch case is used to plot the membership functions, and x and y are truncated as per the given ranges. And then in the next step from line number 46, plotting the rules are done. So in this, in y1, the value of y is calculated for any given input using the inter p1q function, which is a inbuilt MATLAB function. And then area function is used to find the shaded area. Minimum of y and y1 is considered to plot the area below a certain degree of membership. Then ymax is updated by the maximum value of y for the shaded area, which is saved in this ymax1. Similar thing is done for the other input variable, another input variable. And then for the output variable, whether to take the minimum of the shaded area or the maximum of the shaded area, it depends on whether or is used or and is used in between the rules. And finally, this area function is used to get to combine uh, in order combine to form a total area for all the rules in final y. So final y is updated, and then the titles are given on the subplots. And finally, yeah, finally the plotting of the subplot is done, and y is truncated from 0 to 1, and the defuzzification is done by using the centroid, and this formula is standard using the standard formula which is available at mathworks.com. And since gear is a discrete value, so we have to round off the centroid. So this Fuzzy AutoGear GUI is the same file as Fuzzy AutoGear M. This is the main file that is used to develop the app. Just the plotting part is not here in this file. So now these are the plots for the fudgification of the inputs as well as output variables, like from -10 to 30, a triangular membership function representing very low; 20 to 50, triangular membership function representing low; 40 to 80, trapezoidal membership function representing medium; and similarly, the whole input area is covered by the 5 membership function as very low, low, medium, high, and very high. This is for speed. Same thing is done for RPM. Same thing is done for RPM, just a Gaussian membership use, which peak is at 3000. So the whole input range up to 6000 is covered with 5 membership function, and same thing is done for the gear, that is the output variable, the fudgification. And this is the rule viewer that is being generated, creating the final combined plot and defudgification using the method of centroid. Now the app developed is, so this is the final app that is being developed. So in this we can move the sliders by selecting here the value of RPM as well as speed, and the gear change will happen automatically. Suppose I am taking a very low value of RPM below 600 and taking a very low value of speed somewhere around 10-12 kmph. My gear is at first gear is selected. Now suppose I am increasing the speed somewhere around 25 kmph, second gear will be selected. Now suppose my RPM I am increasing up to a medium value somewhere around 3000, and speed also I am increasing up to 70 kmph, third gear will be selected. Now suppose further I am increasing the RPM to a high value 4500, around 4500, and speed is somewhere around 110 kmph, gear is fourth gear. Now suppose I am giving very high RPM somewhere around more than uh, 5800 rpm, and speed is somewhere around 180 kmph, the fifth gear will be selected. So this is how this system works. Thank you.